So hello, today we are going to learn how to assemble the microscope, in particular the light sheet microscope. And so what you will have is most likely something like this, a box full of parts. I will unpack everything and so that you know how to set up stuff step by step. You will have the laptop with openUC2 pre-installed, and then eventually a sample already with a thoroughly labeled sample. So for example, a zebrafish or maybe just some paper, and we'll go through the whole process step by step. You'll also find more of the documentation online in the openUC2 tab. First of all, we have a bunch of cables. So the USB for communicating with electronics, the 12-volt power supply, eventually a syringe to fuel our sample chamber, the cable for your camera, it's a USB, C with a special type of plug. And then the whole light sheet, where the light sheet is already partially assembled. So you will have the XYZ stage here, where there's a syringe in there. And then also the fully assembled light sheet microscope with the laser source that's covered with the fiber, the mirrors, the camera that's not assembled yet, the fluorescent filter, and then also the sample chamber, which is right now not assembled at all. So we'll just put it here for the first setup. This is everything you need. And so in order to get it working, we'll start with the camera. So the camera has to be threaded, if not done already, to the C-mount. So better do it quick, otherwise there might be dust. Make sure that the ring between the CCTV lens and the camera C-mount is there, so that the correct spacing is maintained. And then you can go ahead and adding the cable here. And then we'll be all set on that side. Make sure that all the different cubes are fully fused, and then make a visual check. So the light sheet chamber is magnetically mounted, so you can just slide it in and out. And the first things first, we'll align the light sheet first. So for this, we'll start our computer, where we have openUC2 installed. In the meantime, we'll also carefully add the fiber, make sure that it's not hitting any other part but the guide of the FC mount. And then once this is done, you can add the fibers threading. Make sure this is all set, mechanically tight. And then you can add the camera cable, which is USB 3, to your USB 3 capable laptop. The serial that goes to the electronics. So make sure that the ESP you'll find here gets the right connector. And then the cable is also going into the laptop side. The remaining part is the XY stage, or XYZ in particular. And the XYZ stage should work the way that you have a sample holder. This can be adjusted so that you can hold different samples. In this case, it's a syringe, but you can also have different ones. This one, for example, is not properly mounted yet, so we have to do that in a bit. And this is designed so that you can remove the syringe here. And then you can add this whole part to the mic. So we'll do that now. So theoretically, you can also use M3 60mm screws to fully mount it. But for just quickly testing it, it's just fine to hook it up to the assembly here. So you see there's the bottom plate that fits into the base plate tightly. And then you can add your sample. But for now, we don't need that. First, we want to calibrate the light sheet. And the light sheet calibration works the way that you first turn on the laser and then focus into the liquid filled chamber to line the sheet with respect to the focus. So the focus comes from this side here. So the detection here, easily visible. Just removing that here again. It's an objective lens, the fluorescent filter, the tube lens, and the camera. And the focus here is in the working distance of the objective lens, which is roughly 10 millimeters far away from the first lens surface. So it's somewhere here, and the light sheet is formed in that plane. So we have to make sure that the light sheet is in the same plane as the focus of the objective lens. This we are going to do now. So for this we are going to plug in the electronics to the 12 volts. The USB is already plugged in, so we can just do that now. So the laser is already turned on now, so we know that the beam cannot leave the assembly here, so this should be eye safe for now. Nevertheless, so you can also turn on the laser in the browser using our UC2 browser widget, which I'm going to show you in a second. So what we're going to do now is we will turn on the laser while we are also adding water to our chamber to align the light sheet. And so for this we again take our light sheet. We don't need the sample chamber right now. So we pull this out, fill this with the water, and then we need some more. So we'll fill it with more water, and then we'll see inside the chamber there's no water, and so we have to add some of the liquid here to make the water fluorescent. So this is now inside the chamber here. You see some of the glowy pen here. You shouldn't drink it, but it's a very nice way to align the light sheet. So then we insert that again, and then we're going over to the website. So we connected everything properly. Okay, so we'll start all over again with aligning the laser. For this we'll need a screwdriver, a relatively small hex key here, and also the camera software. Here it's called Galaxy Viewer. It visualizes the camera stream, and then we're going to visualize how the light sheet is oriented in the sample plane. And first of all, we have to turn on the laser. So in order to do that, you go to the online website that gives you full control over the microscope based on UC2. I deny Chrome stuff. It only works in Chrome though. And so you go to uc2.jitab.io, and now that the website is loaded, you click on connect, select the port, and then you are connected to the device. So you can already see that the LED here turned on and off again. So you can control that by the button LED on and off, and you can also control the motor. So this is mostly for a test. So you see here now it's moving back and forth. But what we're going to do is now turning on the laser. So you have full control over the laser. The laser is turned on now. And now we go over to the Galaxy Viewer software, click refresh, but already the camera has been pointed here. So you double click on that and start the acquisition mode here. And what you see here is essentially just a black screen because the exposure time is relatively low. So you can enter exposure time here, and then it will appear. So exposure time, hit enter, and then you can control that. So we set it up to something like 100 milliseconds, just to make sure that we see something. And then if we turn on the light here, so we maybe split screen here, just close that one here, make this a little bit smaller, and then here that put on the right. You can turn on the LED, and now you see that the LED is already turning on, and you see some light here. That's already good. So, so we turn on the laser, which is already turned on, and now we have to find the light sheet itself. So what we have here now is the laser is coming. It's being collimated by the laser collimator, and then hitting the beam here, the mirror, before it's getting focused into the sample plane. And what you see here now is essentially water tinted with the fluorescent pen. We use Stabilo yellow, that works usually quite nicely, and so we have to steer it a little bit in order to distribute the fluorescent particles. And now you see that it's not perfectly in the center, so we have to align that now. So you have 3 screws here, which you can turn, and you see already this is for up and down, this is for also up and down, and then there is one for left right essentially. So it's 3-point mechanism, so you see it's moving. And so what's your goal now is essentially the beam here has to be, well, it's coming out in the center of every cube, hits the mirror here in the center, and then has to go into the back focal plane of our illuminating objective lens. So we have to carefully watch from this side here to see whether we are in the center. So ideally we enter it in the center from perpendicular side, and then we should have a clear focus in the center spot here. So the numerical aperture here of this lens is relatively low in order to have a long light sheet. So it's roughly a focal length of 50 millimeter, and then we'll spot that. The beam, you can use a little paper piece. Make sure that you're not looking into the beam directly. So here you see that the collimator does a nice job. So the beam comes out of the fiber at a collimated state, and then hits the mirror here, and then you see that the beam is here from that side here, hit the mirror, and then go out in that direction. So it should be roughly in the center, so maybe even folding that one more to have more space is required. So you see that like here. And now when you use the screwdriver in order to use this screw here, so you have 3-point mechanism, this here flips the beam like that one like this here, and the point over here is basically rotating, tipping it. So, and then we need to make sure that the beam here is in the center of the back focal plane, and then this is already the case. What you see here, so the RMS thread is in the center. So now we need to move the beam a little bit more to the right hand side. So we do that by rotating this screw here. So then it's moving slightly on the right hand side. And this is about it. And then you can see that the light, the focus is formed in the focus spot of the objective lens here. So let's see that here. Here we have the close-up shot of the light sheet in the sample plane, and you already see that the fluorophores are not distributed nicely, so you can steer it around a bit. It's like a little foggy cloud there. And then by moving the objective lens back and forth, you can then move the focus spot back and forth. So it's only coarse movement, unfortunately. So I think the next version will have a proper focus mount. And then make sure that the light sheet here is perpendicular to the cube surface, so that we have the light sheet parallel to the focus plane of the objective lens here, so that we form a sheet on the sensor end. So here you see that the sheet itself is now parallel to the surface here. That's important. And the focus point, so the point where you have smallest spot, maybe somewhere here, but it has to be in the center so that it reaches the objective lens through the middle. And for this we go over to the camera software again and visualize the light sheet. So what you see here now is the light sheet is completely overexposing our camera, so we reduce the exposure time by quite some factor, so we use by 1 minutes and see how that goes. So now what we have here is the fact that we are completely out of focus, and so we'll lens to the light sheet, so that we can have both in the same plane. For this we go over here and visualize the light sheet. See the intensity is increasing. So what we are essentially doing now is we move the light sheet, the objective lens closer to the light sheet, so that we eventually are in the focus of this lens here. So it's only very little steps because we have to be very precise. So we see that the lens is moving back and forth, and so we have to move it to the position where we expect the light sheet. And once more on the screen, you see that here. So it's on the screen here, there's something like a white line that appears on the screen here, and that's already our light sheet, or in a way it's our focus of the light sheet. And so now we have to align that. So we have to move the objective lens a little bit more carefully, or steer the light sheet, which we have to do anyway because it's not within the field of view right now. So what we are going to do now, make sure that the camera is aligned correctly, so that the light sheet is really parallel to the axis here. And so we have to first move the light sheet a little bit up. So we use this one here. So you see that you can move it up and down a little bit. So there might be some water bubbles. That's why the sheet looks a bit weird. And then we can move it with this screw a little bit closer to the focus. So here there was the focus already. And now you see that the point where the focus of the smallest is already out of the view. So you see it's focusing, and then maybe the point is somewhere here. So we have to move the lens probably in this direction here. So it takes a bit of an effort, but then we have to realign it a little bit because we lost the focus in this direction. So I think that's already pretty good. So that we see a relatively big light sheet is mostly because there's lots of autofocus blur, because there's so much fluorescent background inside the sample. But the focus is now somewhere here, and so it's focusing and going out again. So the next step would be to insert the cylindrical lens again, and so then we'll have light sheet instead of. And so for this, what we do is we turn off the laser, and then we can start going ahead. So now the laser is off, and so we insert the lens here just where it used to be before. So light is collimated, so the laser light is collimated, then light sheet is formed, and then it's projected into the sample plane here. So now we're going to turn on the laser again, so the same thing. So the thing, since we distribute the intensity over a larger area, we have to increase the exposure time again, but now you can already appreciate the light sheet in the sample plane. So the light sheet here now, well, there are some bubbles, that's why it looks so funky on that side here. Maybe there's also some dust in there. We just stir it a little bit, and then yeah, looks already better. So the stripe pattern that's usually apparent from the stuff that's floating around, or yeah, the sample itself. So what we need to do now is probably steer the light sheet a little bit along this direction again. So move it back and forth with the one screw in order to make it aligned with the screen. So we're going to increase the exposure time from 10 milliseconds to say 30, just to find the light sheet. So, and you see already, maybe just increase it because the contrast is quite low, that there is some light sheet apparent. And so we are going to just, with the screwdriver here, move this screw here a tiny bit so that we align it a bit more closely. And then you should see a very sharp stripe pattern in the sample plane, like there. So when you see the little blobs floating around in one sample plane, then you're in focus. So this is how you align the light sheet with respect to the camera. And then now you can differentiate the focus, so the laser light from the fluorescence by just inserting the fluorescence filter. And again, increase sensitivity. Now we do that by increasing the gain, essentially the pixel offset. And here you see that these bubbles are floating around. They're still not perfectly in the focus because they would not be big, but very, very small. Somebody said that they are little quantum dots. I'm not very sure about that. So I think here we are. It's pretty much in focus now and well set up. And so for the next part, you can change the liquid here by simply swapping out the cube here. So it's magnetic, so you can just snap it in and out. We'll leave it for now as it is, but we want to add a sample. So we have the XYZ stage here. We'll mount that here, and then ImSwitch will come into place so that we can move this sample holder in order to steer around our syringe-mounted setup. So we have an open, which is a genetically modified zebrafish. So maybe not quite visible, but this is the tip of the syringe. There's a little zebrafish that has been labeled with GFP. And so we want to have a little scan in 3D by moving that through the focus. For this, we are going to use ImSwitch, and I'll show you that in the next video.